Hello and welcome back to our series in statistics. We're coming to you from the auditorium downtown. And as you can see, we have a number of interested people in our audience. Let's begin. This is presentation 8.1, and we want to acknowledge the development team of Brad, Spencer, and Amanda. Note this material can be found in your workbook and textbook as indicated. Now, as an illustrative problem, we want to look at the consumption of natural gas by residents of Central Alberta, known to be 32.5 gigajoules per month, and standard deviation 6.4. An extensive ad campaign suggests that the significant reduction in the consumption of natural gas taking place. So we do a sample of 60 households. We found that the the sample mean was 32.5 gigajoules, and we want to find if this is significant to suggest that indeed this is a reduction from the 32.5 gigajoules indicated on the screen. And we put the claim here. We're testing if there is enough evidence to suggest the claim is true. So let's begin. Part A, we set up the null hypothesis. The null hypothesis, if you start with the notion of no change, that the mean gas consumption was not significantly reduced, the mean is actually still the same as it was, 32.5 gigajoules. The alternative is that it has changed. As a matter of fact, you're trying to show that there's evidence to suggest it's been significantly reduced. Mu sub x is less than 32.5 gigajoules. Now for this test, we assume that H naught is true, that the mean is somewhere around 32.5. And this means that the distribution of sample means is normal, with a mean central tendency 32.5 gigajoules. Standard deviation given by the standard error on the screen here, 0.826, and that is the standard error in our estimation, and that's the 68% region, about the population mean. Part B, we have to specify now a level of significance of 5%, and this suggests that if our sample mean falls in the left tail here, in a 5% region, the critical value minus 1.645, we're going to reject H naught. If X bar does not fall in this lower tail, up here we're going to fail to reject H naught. And we want to specify that if X bar falls into this critical region, then H naught is rejected. It's referred to as a type 1 error. Now part C is the test criteria. We're suggesting if the Z statistic, which we'll bring up here shortly, is less than minus 1.645, we're going to reject H naught. Otherwise, we're going to fail to reject H naught. And this becomes our test criteria for accepting or rejecting. We've just gone to another screen here where we've summarized the results previously, and we're going to look at part D, which is show me the evidence. To weigh the evidence, we look at the observed versus the hypothesized relative to the standard error. We're going to compute the Z score here. We call the Z statistic or Z observed, and it's X bar minus mu over sigma sub X bar, 30.3 our sample mean, 32.5 our hypothesized value over the standard error. That comes out to be 2.66 with a negative value there. This is indeed less than the minus 1.645, the critical value. And so that falls in this region. We're going to suggest that this constitutes sufficient evidence to reject H naught. Now we're going to go to what's called the p-value. The p-value specifies how rare it is to get an X bar this extreme from 32.5 if H naught were indeed true. And that means that our Z observed is down here minus 2.66, and that gives rise to this region of the tail here. It's called the p-value. Let's compute what it is. A Z more extreme than your observed Z stat, 2.66, and we find that, look that up in the table, and you get 0.0038. So the p-value here is 0.004, which suggests this extremely rare event if H naught were true. And we're suggesting this argues strongly against H naught and suggests that HA is most likely true and the claim is validated. That's the end of presentation 8.1. Please review it once again, take notes as required, and go to presentation 8.2.